Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, I want to discuss about exact differential equations. So here in this video, we are going to know about what is exact differential equation. So what type of problems will be there in exact differential equation and how to solve these type of problems. So first of all, what is the ordinary differential equation? We can see here, an equation is said to be ordinary if the derivatives have reference to only one independent variable. So in the ordinary differential equation, we are having only one independent variable. So coming to partial differential equation, the partial differential equation is said to be partial. The derivatives in the equation have reference to two or more independent variables. So in the ODE, we are having only one independent variable, and in PDE, we are having only two or more independent variables. So here, we can observe the difference between ODE and PDE. So these are the examples of ordinary differential equation. So dy by dx plus 7xy equal to x square. So here, y is the dependent variable and x is the independent variable. How we can say that y is the dependent variable means, here when you are doing the partial differentiation with respect to x on y, so then y is changing depending on x. So x is the independent variable and y is the dependent variable. The same way we can observe in the second equation also, d square y by dx square plus 3 into dy by dx plus 2y equal to e power x. Here also y is the dependent variable and x is the independent variable. Here we done the differentiation 2 times. So we can observe here partial differential equation dou u by dou y equal to minus dou v by dou x. Here two independent variables are there, y and x, and dependent variables u and v. So here these are the classification of first order differential equation. So one is variable separable and homogeneous and non-homogeneous, exact equations and reducible to exact equation, nothing but non-exact equations, and linear equations and Bernoulli's equation. So in this we are going to learn about exact equations now. So what is the exact differential equation? We can observe in this definition, let m of x comma y into dx plus n of x comma y into dy equal to 0 be a first order and first degree differential equation where m and n are real valued functions of x comma y. So here we can observe the form m dx plus n dy. Here m and n are real valued functions of x and y. So then m dx plus n dy equal to 0 is said to be exact differential equation. So this is the form of the exact differential equation. If there exists a function such that d of f of x comma y is equal to dou f by dou x into dx plus dou f by dou y into dy. So this is the form of exact differential equation. What is that? M dx plus n dy equal to 0. So here how to identify? So how we can say that this is the exact differential equation? We are going to see here one condition is there. So this is the condition for exactness. So how to identify or what is the condition to know about the given equation is exact or not? We can observe here, if m of x comma y and n of x comma y are two real functions which have continuous partial derivatives, then the necessary and sufficient condition for the differential equation m dx plus n dy equal to 0 is said to be exactness, that is dou m by dou y, that is dou m by dou y is equal to dou n by dou x. That means we have to observe the values of m and n. After then, we have to do the partial differentiation of m with respect to y. And here we have to do the partial differentiation of n with respect to x. Then these two values should be equal. So this is the condition for exactness. So after getting the equation, we have to check about this condition. If it is satisfied, we can say that this is the exact differential equation. So here now after identifying the exact differential equation, we can find the general solution. So general solution of exact differential equation is here integral m dx plus integral m dy equal to c. So here when you are doing integration, we have to take y as constant in the n. We have to take y as constant. When you are doing integration for the n, we have to take only y terms. So free from x means only y terms we are going to take here. So how we can take only y terms, we can observe in the example problems. So here in this slide we have to know about what is the condition for the exactness. So condition is dou m by dou y is equal to dou n by dou x. Then only we can say that the given equation is exact differential equation. If they are asking to check about the exactness means we have to satisfy this equation only. Here in the problem what we have to solve. So first step what we have to do, in the first step we have to know about what is m and what is the n value. In the second step we are going to find about dou m by dou y and dou n by dou x value, and after then we are going to check these two values are equal or not. These two values are equal or not. If those are equal, then we are going for the general solution. These are the steps we are going to follow to solve the exact differential equations. So we can observe here in problem. See, solve e power y plus 1 into cos x dx plus e power y into sin x dy equal to 0. So here what they are giving? Given equation is e power y plus 1 into cos x dx plus e power y sin x dy is equal to 0. So here after getting the equation, what is the first step we are going to do? We are going to compare with the exact differential equation. The form of the exact differential equation is m dx plus n dy equal to 0. So when you are comparing with this equation, this is the equation 1. So equation 1 is comparing with the second equation. So comparing given equation with equation 2. So here by observing what is the m value, here e power y plus 1 into cos x dx, that means m value is e power y plus 1 into cos x. And what is the n value? So n value is e power y sin x, n value is e power y sin x. So what is the third step we are going to do? We are going to calculate dou m by dou y value. So what is the dou m by dou y value? Here we are going to do the partial differentiation of m with respect to y. So here when you are doing the partial differentiation with respect to x, we are doing means y is treated as constant. If you are doing with respect to y, x is treated as constant. So here I am doing with respect to y, that means x is constant. So here first I am writing the m value is e power y sin x, e power y cos x plus cos x. So here when I am doing with respect to y, x is the constant, that means cos x is constant. So differentiation of e power y is e power y. Y value is 1. Plus here this complete value is x only, so constant, this is 0. This value is e power y cos x. This is the value of dou m by dou y. Now I am going to calculate dou n by dou x. What is the n value? E power y sin x. When I am doing with respect to x, y is treated as constant, right? So e power y is constant. So what is the derivative of sin x? Derivative of sin x is cos x. Now So dou m by dou y value is e power y cos x. Dou n by dou x value also e power y cos x. So finally here dou m by dou y is equal to dou n by dou x. Dou m by dou y is equal to dou n by dou x. That means this is the exact equation. This is the exact differential equation. So after finding this value, what we are going to do? We are going to find the general solution. What is the general solution? Integral m dx plus integral n dy equal to c. So here what we are taking for the m, we are going to take y as constant. Y treated as constant. When you are calculating for the n, we are going to take only y terms. So we are going to take only y terms. So first of all, integral, what is the m value? M value is e power y cos x plus cos x into dx. This is the m value. Plus integral. Here in the n value is e power y sin x. There is no separate n term. So separate y term. So that's why we are taking 0. So integral 0 dy equal to c. So integral e power y is the constant. So taking out. So e power y integral cos x dx plus integral cos x dx equal to c. So finally here e power y integral cos x is sin x plus integral cos x is sin x equal to c. So finally when you are taking the sin x common, this is e power y plus 1 equal to c. This is the general solution of given equation. So this is the general solution of given equation. So this is the way to solve the given problem. So we can observe here. So given equation is e power y plus 1 into cos x dx plus e power y sin x dy equal to 0. Now we are comparing this one with the exact differential equation form, that is m dx plus n dy equal to 0. So here we can take m value is e power y plus 1 into cos x and n value is e power y sin x. So when you are calculating dou m by dou y value is e power y cos x and dou n by dou x value also e power y cos x. So these two values are equal. So dou m by dou y is equal to dou n by dou x. So therefore this equation is exact differential equation. So after calculating this value, we are going to see the general solution. So general solution is integral m dx plus integral n dy equal to c. So here when you are doing for the m, so y is treated as constant, and when you are doing for the n, so we are going to take only y terms, So here we can observe m value is e power y plus 1 into cos x dx, and here there is no separate term, separate value in the n, y value not having only y value in the n. So that's why we are taking here 0. So finally when you are integrating the function e power y plus 1 into integral cos x is sin x. So finally this is our general solution, e power y plus 1 into sin x equal to c. We are going to see one more example. See the problem. Solve x into e power xy plus 2y into dy by dx plus y into e power xy equal to 0. So here we are going to see the solution. First we are writing the given equation. The given equation can be written as, how we can write this one? So here first the given x e power xy plus 2y into dy by dx plus y into e power xy equal to 0. So now I am multiplying with the dx here. So x into e power xy plus 2y into, when I am multiplying with the dx here, dx will be cancelled, I will get only dy here plus y into e power xy into dx is equal to 0. So now I got here the values. So m dx plus n dy. So now the form is m dx plus n dy equal to 0. So sometimes what we are writing first term as a m and second term as a n. So not always write that one. So why? Because we have to check the equation properly. In this problem, you can observe here. First, we are getting this value with the dy. That means this is the only n value. So that's why we have to check and take the values properly for the m and n. So here m value is y into e power xy. M value is y into e power xy, and n value is x into e power xy plus 2y. E power xy plus 2y. So that is only we can observe here. When you are comparing with the equation, m value is y into e power xy and n value is x into e power xy plus 2y. So now after taking the m and n values, we are writing here dou m by dou y value. So what is the dou m by dou y value here? So here I am going to do the partial differentiation with respect to y. So then here two terms are there. I am going to use the formula derivative of u into v formula. So here u dv plus v du. This is the formula for the u into v. So that's why first u means y. Y into derivative of e power xy. That means here derivative of e power xy is e power xy into here with respect to y I am doing. So x is the constant, y value is 1 plus e power xy is the constant. Now derivative of y is 1. So now finally y xy into e power xy plus e power xy. So finally this value is, I am taking e power xy common. So xy plus 1. This is the value of dou m by dou y. Now I am going to do dou n by dou x value. So what is the dou n by dou x value here? So this one. Here also we are going to do the u into v form. So that is x is constant. So derivative of e power xy is e power xy. And into here, when I am doing respect to x, y is the constant. So y into x is 1 plus. Now e power xy is the constant. Derivative of x is 1 plus derivative of 2y. So 2 also constant, y also constant. This value is 0. Now this value is xy into e power xy plus e power xy. Now I am taking e power xy common. So then xy plus 1. Then xy plus 1. So dou m by dou y value also e power xy into xy plus 1. And dou n by dou x value also e power xy into xy plus 1. So dou m by dou y is equal to dou n by dou x. Dou m by dou y is equal to dou n by dou x. Therefore, this is exact differential equation. This is exact differential equation. Same thing we can observe here. Dou m by dou y value is and dou n by dou x value. So both are equal. So if these are equal, what we have to do the next step? The next step is we are going to find the general solution. What is the general solution? Integral m dx plus integral n dy equal to c. So here for the m, y is constant. Here when you are doing for the n, only y terms. Only y terms. So based on this, so integral m dx plus integral n dy equal to c. So y is the constant and we will take only y terms here. So what is the m value? Integral y into e power xy dx plus here. What is the n value? N value, see here. N value is x into e power xy plus 2y. What is the n value? X into e power xy plus 2y. Here in the n, we can take only y term. So what is the only y term we are having in the n? So 2y. So that's why we are taking here y n value is 2y. If you have separately n y value, we can take it. And if there is a possibility to separate that term for the n, we can take it. So like that, we can calculate the value. So here 2y. So integral y dy equal to c. So here integral y e power xy dx plus integral 2y dy equal to c. So now I am doing the integration here. I am doing with respect to x. So y is the constant. So integral e power xy dx plus 2 is the constant. Integral y dy equal to c. So here y integral e power x form is integral e power x. That means e power x by here I am doing with respect to x. So y is the constant. Y into x value is 1 plus 2 into integral y is y square by 2 equal to c. So y will be cancelled. Here 2 will be cancelled. Finally I will get here e power xy plus y square equal to c. E power xy plus y square equal to c. So this is the general solution of the given equation. You can observe here the solution. So e power xy plus y square equal to c is the general solution. So what is the important thing you have to remember here? When you are taking the n value, if there is separate y term, we can take it. If there is no possibility to have the separate y term, we will take n value as 0. If there is a possibility to split the value to take it and y value, we can take from the n. So this is the important thing we have to remember here. We are going to see one more example here. Solve cos x minus x cos y into dy minus sin y plus y sin x dx equal to 0. Here the given equation is, what is the given equation? Given equation is cos x minus x cos y into dy minus sin x plus y sin x, here sin y, sin y sin x into dx equal to 0. So from this we are going to compare with m dx plus n dy equal to 0. We are going to compare with the equation m dx plus n dy equal to 0. So what is the m value and what is the n value? We are going to see here. So what is the n value here? N value is cos x minus x cos y. This is the n dy, right? So n value is cos x minus x cos y. And what is the m value? M value is minus of sin y plus y sin x. Nothing but minus sin y minus y sin x. Now after getting these values, we are going to calculate dou n by dou x and dou m by dou y values. So here I am going to do dou n by dou x here. So what is the differentiation of cos x? Cos x is minus sin x. Minus, when you are doing with respect to x, y is the constant. So cos y is the constant, x value is 1. So finally this is minus sin x minus cos y. This is the value of dou n by dou x. Now I am going to do dou m by dou y. So with respect to y, I am doing minus sin y. Sin y derivative is cos y and y is 1 minus. Here with respect to y, I am doing x is constant. So sin x is constant, y value is 1. So finally this is minus sin x minus cos y. So here also minus sin x minus cos y. So finally we got the value dou m by dou y is equal to dou n by dou x. So therefore this is the exact differential equation. You can observe the solution here. So this is the dou n by dou x value and dou m by dou x value. Both are equal. Therefore this is the exact differential equation. After finding that, what we are going to find? We are going to find the general solution. What is the general solution? Integral m dx plus integral n dy equal to c. So at the m we are going to take y as constant. At the n we are going to take only y terms. So see here the general solution. What is the value of m integral minus sin y minus y sin x into dx plus integral. So when you are taking the n value here, minus cos y and here n value cos x minus x cos y. There is no y separator. So that's why we are taking this one as a 0 equal to c. So integral minus sin y minus y sin x dx plus integral 0 dy equal to c. So now here integral sin y is, what is the integration here? Minus sin y into dx minus integral y sin x into dx plus 0 equal to c. So when I am doing with respect to x, y is the constant. So minus sin y is the constant. So integral dx minus here with respect to x, y also constant, integral sin x dx equal to c here. So minus sin y, integral dx value is x minus y into integral sin x. Integral sin x is minus cos x equal to c. So finally minus of x sin y minus x sin y plus minus into minus plus y cos x equal to c. So finally this value is y cos x minus x sin y equal to c. This is the general solution. This is the general solution of given equation. So see here, this is the procedure we are going to solve the exact differential equation. What is the steps we are doing here? So first step is we have to compare with m dx plus n dy equal to 0 form. After that we are going to find the what is the m value and what is the n value. So then we are going to calculate dou m by dou y and dou n by dou x values. So then dou m by dou y, it should be equal to dou n by dou x. Then we can say that this is the exact differential equation. So finally, after that we are going to find the general solution. These are the 4 steps we are following here to solve the exact differential equation. And moreover, you should know about what is the differentiation and what is the partial differentiation and formulas for the differentiation and integration. So then only you can solve this type of problems. So to get the more problems and about the formulas, you can go through these references books. So BS Gravel, the title is IARE Engineering Mathematics, and a textbook of Engineering Mathematics written by N.P. Bale and Manish Goyal. And we can refer one more textbook also, that is Higher Engineering Mathematics written by V.V. Ramana. So these are the references textbooks. If you want to go, you can go through these textbooks to get some more examples about the exact differential equation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.